these questions will ask us to go write it in vertex form. That's what it's asking us to do. So all we need to do is partial factor and identify what the vertex might be, or what it is, not what it might be, and then write. Once you have the vertex, it's easy to write it into vertex form, right? So what we said the other day was, if I pick some arbitrary point, same y value, in this case it's the y-intercept, we're gonna get, I'm gonna pick 29 as the y value. I'm gonna solve for both x values that correspond with that 29, right? So it's 3x squared minus 18x plus 29. And then if I subtract 29 from both sides, I'm going to get 0 is equal to 3x squared minus 18x. Is that okay? It's pretty much whatever the y-intercept is there, just substitute it in for y and solve for the two x values that give you that y value. That's all we're doing. One of them is going to be 0 because it's the y-intercept, and the other one I don't know what it is yet, but we'll do it. So I can do from here, I can factor out a 3x and I'd be left with x minus 6, right? So x is going to equal 0 and x is equal to 6. Because when I substitute, the whole premise of this was founded in, this is the y-axis, it's founded in the idea that one of the points is 0.29, the y-intercept, and somewhere over here, now we know what it is, over here it's 6. 6 is also 29. Does that answer your question or no?
And that's like a quadratic?
It's a quadratic, yeah. And then I know, in the interest of producing the vertex, or writing it in vertex form, I know the axis of symmetry is in the middle. And I know somewhere along that axis of symmetry lies the vertex. I don't know where, it doesn't matter, that's so I can figure out. But in order to figure it out, I first must be able to, I have to find that axis of symmetry. Which we go, 0 plus, this is easy because it's always 0, right? 0 plus 6 divided by 2. Right? And it's an equation. So it's an equation, that's the axis of symmetry. And now I have an x value, have an x, find y. How do you find y? You got an equation. Yeah, you got an equation up here. You solve for the y value. Y is going to equal 3 times 3 squared minus 18 times 3 plus 29. So that's 3 times 9 minus 54 plus 29. Is it 2? Does it work out to be 2?
I hope so.
Y is going to equal 27 minus 54 plus 29. What's that work out to? 20. Yeah. What's that work out to? That's about right, eh? 2. So your vertex from this information is 3 and 2. Okay. And subsequently, now that I found out that, once I know the vertex, I can write out my vertex form, right? Remember, we're going to write it as a x minus h squared plus k. The a value for quadratics can't change. Just because you switched it from form to form, the a value doesn't just magically change, otherwise it'd be a different graph. So the original a value was 3, that was right here, right? And so we're going to get y is equal to 3 times the h value is the horizontal translation, right? Where did the graph go? It went to the right 3 units. So it's x minus 3 squared, and then it would have been moved up 2 units, right? For the y value of the vertex to be up there. That's it. once you have that, you can solve for the roots if it asks you for that, right? That's what we did on the quiz today,
Yeah. So we,
right? So you could say, okay,
really hard.
the roots would correspond with the points here that the y value is equal to 0.
Yeah, well, 100 meters is like 20 seconds.
Okay, but what's the catch here though? Let's be careful with this. Our vertex, this is not an accurate diagram, is it? Because our vertex lies above. It's right here, 3, 2. It lies above, and we know that it's opening up. How many roots would it have? It doesn't have any roots. And I know it's opening up because the a value is positive there. Okay, so this one doesn't have any roots.